Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan, and today we've got Chris Larsen, Senior Director of Clean Energy for Dynapower. Excited to talk with Chris today. Hey, Chris, welcome to the podcast. Great to see you.
Ted, great to be here.
And where are you sitting as we speak? Are you in Burlington, Vermont as we speak?
I'm not in Burlington. I'm actually up in Buffalo, New York. I was up here for the Bills game yesterday, so I'm a bit out of my element, but all's well.
All's well because you're a Bills fan, and they eked it out apparently. Let's go
in
with
this particular case. Hey, a win's a win.
Yeah. Now I've already introduced you as the Senior Director of Clean Energy at Dynapower, and we're going to get pretty heavily into your current works. But if you could just give an elevator pitch about what Dynapower is.
Yeah, sure. So Dynapower is a power electronics company that's been building world-class power electronics since 1963. So it's been around for just over 60 years. We just had our 60th anniversary last month, which is pretty cool. And Dynapower is, it's interesting, Ted. You look at sort of who we are and where we came from as a company. Founded in Detroit by John Pollock back in 1963, really to provide power electronics for the auto industry, more specifically to do the metal surface finishing for the auto parts industry. We did all the power supplies that fed into the machines that would finish the metals that went into the cars into Detroit. So that was our power electronics heritage. And so doing this work, and then the company evolves. It's a family company. John's son Peter Pollock takes over the company, and Peter, who had taught at the University of Vermont, taught high energy physics at the University of Vermont, had fallen in love with Vermont, and when he took over the company from his father, said, "Hey, we're going to move the company to Vermont." His father thought that was the craziest thing he'd ever heard, but anyhow, It actually happened. 1989, relocated from Detroit, and basically 90% of our customers at that time were within a 50-mile radius of Detroit. So you can imagine how risky a move that was. But so for lifestyle reasons, we were moved to Vermont.
Yeah. Not bad.
Not bad at all. And what's happened, the evolution is really interesting because we went from, if you look at us today, so if somebody unfamiliar with Dynapower goes to our website, says, "Oh my goodness, this company is all about clean energy, really focused on electrification, clean technologies." And it seems like quite a departure from our original roots, but we've maintained the work that we do in the metal finishing industry, and we've expanded that quite a bit. And we've managed to really build a fantastic business around the work that we're doing in clean energy, but also maintaining the work that we do in high efficiency power electronics for the industrial space. So that core business is still there.
Right. Let me drill into that core business just for a second. Maybe you can dumb it down a little bit, because your point, you use this term power electronics, and I kind of I'm thinking very simplistically. You got these utility lines coming in to a facility, I guess in this auto industry facility for metal finishing or something. The wires arrive, and then I always call it the switch gear, where the wires arrive and where you've got the meter. Mm-hmm. Is it the switch gear that you're calling the power electronics? I mean, educate me.
Yeah, so we would pick it up on the other side of the switch gear. So no, the switch gear is something separate. And we actually don't really do any work in that particular space. So imagine in simple terms, we're basically taking, for that application, Ted, we're taking the AC from the grid power, AC, and converting it to DC. So it's a rectifier in that particular case. We might generically call it a power supply, but really we're rectifying that AC, converting it to DC. And as our business has evolved, we've done a lot of other configurations as well. So we also do the opposite direction. In fact, a lot of the work that we do in clean energy is the opposite direction, where we're taking DC from batteries, for example, or from ultra caps, and then converting it to grid quality AC. In hydrogen, we're going the other direction, again, from AC to DC, providing high current DC power for the electrolyzers.
Yep.
And then we
Yep.
also do DC to DC, right? We take DC of one voltage and convert it to DC of another voltage. So any conversion, that's the power electronics, and that's our sweet spot.
Very interesting. Let's go all the way back. I know you did your education in New Jersey at Princeton and then also in North Carolina, your master's. But I think in your note to me, you said you grew up in Central Florida. Is that right?
This is true. Yeah, I grew up in Winter Park, Florida, just north of Orlando. It's funny, my mom was always good with puns. So we grew up near, all the amusement parks, right, in the Orlando area. So instead of the better mousetrap, my mom would say that we lived in the world of the mouse that built the better tourist trap. And so yeah, I grew up down in the land of Mickey Mouse. And the reason we had ended up there was my father grew up on a sugarcane farm in South Florida. So my grandparents immigrated back in the 30s. My grandfather was quite the entrepreneur. So he co-founded this the sugarcane farm on the southern shore of Lake Okeechobee. He even invented a harvester that was used in the industry for years. He got a patent on it and all that. So quite the entrepreneur. But so that was important for me because growing up, we'd go down there to the farm every once in a while. It was about 3 hours south of where we lived in Orlando. And right before harvest season, they actually burn the sugarcane fields. So imagine this giant 40-acre sugarcane field. And there are men walking through there with these kerosene torches, literally burning it. And you think, what in the world is going on? Are you burning your crop right before you harvest it? Well, the answer is you're burning off the leafage, right, to make it easier to harvest. So after the fire runs through, miraculously, it doesn't burn the stalks, but it burns the leaves, leaves the stalks, and then much easier to harvest. And so I witnessed this as a kid, and I'm thinking, holy crap, look at this. This fire, the smoke is this really deep, dark brown, and there's black ash raining down, and you see all the animals running out of the fields, the rabbits, the birds trying to escape from the fire. I think that was my first sort of exposure, not exposure, but I should say my first time when I thought, whoa, we're doing something to the environment that just kind of doesn't look right. So that sort of set an imprint on me as I was growing up. We'd go down there and I'd see this and be a bit blown away. And, later on in high school, I got a bit older, and this would have been like the late 80s, early 90s. There's a lot of talk in the press down in Florida about the pollution from the sugar industry, because for those who aren't familiar with Florida geography, you've got Lake Okeechobee, that's the big blue dot at southern Florida, and then you've got south from there the Everglades, and right in between is where all the sugarcane is grown. So there's a natural water flow between Lake Okeechobee and the Everglades, and so it's flowing right through the sugar. The groundwater is flowing right beneath the sugar fields, and so a lot of pollution was getting, agricultural pollution was getting into the Everglades. And so I developed this sort of awareness in high school about some of these impacts, and maybe I might be overstating it, but felt like I maybe carried some guilt about this. Meanwhile, I developed sort of a geeky side and was doing science fairs and all that. And so when I got to college, I got really lucky and kind of got connected up with a group in the mechanical engineering department who was really influential in the renewable space, doing some really cool work. And I got involved with a research team that was specifically looking at biomass gasification to be produce biogas that could be dried and cleaned and then run through gas turbines. So a pretty novel renewable energy source. And so I came out of college as I was a renewables guy, but I didn't know what the heck I was going to do. But I studied biomass, studied a little bit.
Is there a link between the sugarcane operations and the biomass opportunity?
I've wondered that, Ted. I've thought about that. I'm sure that there is some distant link. It turns out that really what I was studying was switchgrass up in the northern Great Plains. So a rather different climate. But I had thought about that. Hey, I wonder if my interest in these in biomass dates back to my own family's agricultural roots. But what actually happened though, Ted, was that right after college, and again, I knew I wanted to be in renewables or energy, but didn't really know what to do. And
Hmm.
my best friend at the time had found he had discovered this magazine. That wasn't a magazine; it was a Real Goods catalog. And Ted, I bet a lot of your listeners are familiar with Real Goods.
Yep.
It
Yep.
was founded by John Schaefer in 1978. So this thing, and it's a great catalog. It's still around today. Anyone who wants to take their home off grid, their RV, they want batteries, they want solar. You go to Real Goods and you can get your stuff. And they also had great
Yeah.
articles. So it wasn't just a
Yeah. Yeah.
catalog, but a really cool publication. So my best friend, he found this thing, and that I think of it as like it was almost like a middle school boy who'd found a Playboy magazine. Man, this was his Bible, and he was an evangelist. And so he got the solar bug, and I think I caught it from him, so to speak.
Yeah.
And so my soon thereafter, my first real job was at the North Carolina Solar Energy Center in Raleigh, North Carolina. So that's what took me to North Carolina. He ended up going to the South Face Energy Institute in Atlanta, and we've both been in the industry ever since.
Great. Great.
Oh yeah, South Face was a very influential organization. Yeah, and I was lucky. I was pretty excited to be at the North Carolina Solar Center. We had some really important people in the industry have gone through there. Guys like Larry Shirley, Bill Brooks, Steve Calland is still running the Solar Center there, and yeah, it was a really influential time for me.
Yeah, that's fantastic. Then off to ABB. It sounds like from your resume.
Yeah, I spent some time at ABB, and that was a really interesting journey for me. I started out there doing inverter design. We were basically trying to take motor drives and with a few turns of the screws, so to speak, turn them into photovoltaic inverters. The funny thing about that, Ted, is that this is way back in year 2000, and we were talking about a big solar inverter was 40 kilowatts. So for your listeners who know energy, 40 kilowatts that's a baby inverter today. But at the time we were designing a big, quote unquote, big 40 kilowatt inverter. But yeah, I spent some time at ABB and found myself kind of drifting away from renewables, which is why I ultimately left ABB, was to sort of get back into the solar side of the world.
Right. Well, before we leave, because I think you were doing that DC to DC conversion work at ABB, right?
That actually, the DC DC work that I was involved with, that's Dynapower era. That's quite a bit more recently. That was work that we first started doing in, I'm just going to say roughly 5 years ago, 6 years ago, and pretty cool stuff. We're still doing a lot of DC work now. We've kind of made our name for ourselves in that particular space.
And what would the application be? I mean, I always think of my solar system here on my roof. Power's coming off, it's DC. I've got a car over here with a battery bank in it. Is that my DC to DC opportunity sort of at a residential level? Is that the primary opportunity?
Yeah, it's a good question. So the short answer is that probably not. Now we're not quite there yet. So probably what's happening at your place, or what a lot of folks would have if they've got a solar array at home and they've got their car charger. What's usually happening at 9 times out of 10, or more like 99 out of 100, is that solar DC is being converted to AC,
right?
And then that AC is then being converted back to DC for the vehicle. So the DC work that I'm referring to is more for these larger, what we call front of the meter solar plus storage projects. So these are bigger sort of typically utility scale type projects where every point of efficiency counts, right?
Yeah.
In order for these projects to pencil out financially, it's really important to optimize them for highest efficiency. And so in a lot of scenarios, Ted, the reason for doing the DC, having this DC-DC converter is, imagine you've got this solar array, and the solar is producing DC, and then you're converting it to AC and pushing it out to the grid. Well, what if you wanted to store some of that solar
Yeah.
before you push it out to the grid? And there are a lot of reasons to do this, right? There's you may want to you may be harvesting solar in the middle of the day and you don't need it, right? This is the famous California issue, what we call the duck curve, right? You have too much solar in the middle of the day. Well, hey, if you can store that, and there may be other reasons to store it as well, but if you can store it and then export it at times when the grid needs it, hooray. So we've been doing this for years and years and years, but then the idea was, well, wait a minute, if we convert the DC solar to AC, and then we got to convert that AC back to DC to charge the batteries, we're being pretty inefficient about the whole thing. So why don't we just keep it DC? And so we use the DC-DC converter to take that DC solar and then convert it directly into the right voltage for your DC batteries.
Now, this is going to seem like a really naive question to you, but I'm going to go for it. We're working for a golf club or golf course, a country club, and we're putting solar on their golf cart barn. Now, all those golf carts have a DC battery, right? And the solar's DC. Is there any way we can charge those directly and avoid that inefficiency of converting to AC and then back to DC?
You
It sounds
could,
like not yet.
you could. I don't. It's funny though. Well, no, I'm not even going to say that, because I'm going to profess my ignorance, because my our team's area of focus is really on these bigger systems. So
Yeah.
I can talk your ear off about DC coupling for these larger front of the meter systems, but I couldn't even tell you, Ted, who has the equipment to do exactly what you're talking about, sort of at the commercial or small commercial scale. But the short answer is you absolutely could do that.
Sure.
And there probably are people doing it, but I don't want to spread any false rumors one way or the other, because I would be way out of my league and talking about that stuff.
Well, that's great. I appreciate guys and gals that are just like, hey, I don't know. I can get back to you on that if you want. Well, then what scale are we talking? I took note when I was getting ready to interview you. You're working with large scale battery storage systems. You said sort of, utility scale, but how many megawatts and megawatt hours are we? What is large scale, where you start to pick up that efficiency that we're talking about? Over a megawatt?
So yeah, well, certainly well over a megawatt. And again, Ted, it's so funny how the industry is growing so fast that our sense of magnitude has changed.
Yeah.
Right. I was talking before about a large 40 kW inverter, which is, nowadays would be considered rather small. So a large system these days would be something in the order of magnitude of 50 to 100 megawatts plus. Okay.
Mm-hmm.
So
Yeah.
a 10 megawatt project, and as crazy as this sounds, we would consider a 10 megawatt project to be, small to medium size. Right.
Yeah.
So it's only when you get up between 50 and 100 do you start maybe calling it large. So yeah, it's exciting. I mean, listen, what that means is that the industry is doing what it needs to do, right? It's scaling up to actually have a material impact on the utility grid. If we're still talking about 1-2 megawatts, that's fantastic. First of all, I should say, the 1-2 megawatt, the 100 kilowatt work at the commercial industrial level, we do a lot of that, and it's very important work, and we need that to continue. But at the same time, these large grid scale projects are having a hugely positive carbon impact, and they're getting bigger and bigger, and it's pretty mind blowing.
Yeah.
Sometimes
Yeah, it is. Oh,
numbers.
It is. You're a battery expert. I'm always asking this question of folks that are in the battery space. I always call, where we're at is sort of the lithium ion revolution, right? Lithium ion batteries are just the rage. They're enabling the EV transition. They're coming into our homes, but a lot of experts don't think that's the ultimate chemistry. There's so many different chemistries. Are you optimistic that we're going to end up with a better chemistry or better chemistries, plural?
Yeah, a better chemistry. So yeah, I'm gonna, this is where I've got to be a little bit of a politician, if you know what I'm saying. So listen, the reality of the battery space right now is that there are a lot of emerging chemistry, a lot of technologies coming into the space. There have been for years. There are many dozens of different viable chemistries, and what we're seeing right now that I think is interesting is there's a transition. And listen, you're absolutely right that right now lithium ion is the heavyweight. I mean, you look at the installations that are out there today, almost all of it is lithium ion. But the transition that we're witnessing is that duration batteries. So lithium ion, for reference, is really great for applications where you need 30-minute storage, 1 hour storage, 2 hour, 4 hour. When we get above 4 hours of battery energy storage, typically that's when other chemistries become a more viable option than lithium ion. And so the story really is that there is a place for both the non-lithium chemistries as well. And what the market is saying, though, right now, and this is both domestically, but we're also seeing this internationally, Ted, is that there is greater and there's growing demand for longer duration storage.
Yeah.
So ergo, these non-lithium technologies are starting to see their day in the sun, so to speak. And it's pretty exciting. We're seeing some very well-run companies bring these chemistries to market. Well, and you know how it is, Ted. You can have a great idea and maybe not the best company, or vice versa, but you really need both. So we're seeing some really great chemistries being promoted by some really solid companies, and I'll tell you, it's exciting. So always a place for lithium. There always will be, and yet there's growing space for some of the non-lithium ion technologies as well.
Very, very impressive what's happening with like EV range because of better and better batteries being manufactured at lower and lower costs. And then I know that I think you're bullish about hydrogen. I'm bullish about hydrogen, green hydrogen. Is that right that you're bullish about hydrogen?
Yeah, absolutely, absolutely. It's a big it's a big transition that's happening right now, and that is the investment that's going into these green hydrogen projects. And of course, I guess we should define what we're talking about. Why are we saying green hydrogen? What's interesting is that not everyone's aware of this, that there's a pretty massive hydrogen economy that's already out there, right? There's hydrogen being used today in all kinds of industries, right? From refining to ammonia production, steel production, cement, et cetera, et cetera. So there's a big hydrogen economy, but it's being produced through, fossil fuels, right? Coal, natural gas, that sort of thing. So when we say green hydrogen, we're talking about hydrogen that's being produced via solar, wind, or other renewable assets. And so what's happening is typically green hydrogen is produced where you're taking quote unquote green electrons from renewables and powering an electrolyzer, right? Where we imagine a tub of water. Again, I'm gonna oversimplify this, but the electrolyzer manufacturers would hit me over the head if I tried to make it sound this simple. But basically, imagine you've got you're splitting the water, right? You're splitting that H2O molecule.
You're just taking that tub of water. You're taking the tub of water and just dropping big power cords into that tub of water.
Yes, that's basically. I mean, there's a little bit more going on there, but that's basically it. So Dynapower. Listen, we get really when people say, hey, we need a whole lot of power, or we need a whole lot of DC power specifically, we get really excited because that's what we're particularly good at. So we realize that we've been making these high power rectifiers for other industries, other applications, including the one I described earlier, for metal finishing. We said, well, wait a minute, this is more or less what the hydrogen electrolysis industry needs, right? Higher current, lower voltage DC. We're really good at that. And so we've gotten involved in that space and working with a number of electrolyzer manufacturers. And it's very exciting. In fact, we're right now working on a project, delivering units for a project in Utah. And which I think it's a really cool story, Ted, because it's sort of the next of green hydrogen and energy storage. Because you say, well, why are you doing a project in Utah? And the reason is there's these giant salt caverns in
Yeah.
Utah, and they're using the salt caverns as the storage repository for this hydrogen that's going to be produced using solar out there in northwestern Utah. So it's an existing site. There's a coal plant there today, and they are using high current DC, or high voltage DC, HVDC, to pipe that coal power down to Southern California. Ted, we want to keep your lights on down in Southern California. So some of the power is coming from Utah, and there's a big effort underway led by Mitsubishi and a number of other players, the Intermountain Power Authority, to convert this into a green facility with solar, green hydrogen production, this massive storage facility underground.
It's a great story of the Intermountain project. You know, I worked in LA in the power sector, and a lot of the guys that were retiring had been part of building that power plant and all the transmission capacity down to LA and Southern California. And now it's being part of a whole master scheme involving hydrogen. Really, really interesting. I wanted to ask you about, because you had sent me a note of things that I might ask you about, and this piqued my interest. But you said growing a team of emerging industry leaders, and what do you mean by that?
Well, I suppose, Ted, you can see my gray hair. Maybe your listeners can't, but as I get a little more progressed in my career, I suppose I feel that a lot of my responsibility now and energy and effort really should be toward trying to help build up the industry. That is, help attract, recruit talent into the industry and get folks excited about the kind of work that we're doing. And so, I'm now in a position at Dynapower where, I'm responsible for helping to build a team, and it's a lot of fun, and it's hard, but we've got a great team, and I think we do a pretty good job, really building a culture where we've got folks who trust each other and have a good time and work hard, play hard. But it's again, I think a lot of what I have left to contribute to the industry is really more perhaps more on the people side than on the technology side. As much as I still consider myself a geek and love to get up to the whiteboard and draw diagrams of this, that, and the other. I think a lot of for folks like us who have been in the industry for a while, it's important to help bring up that next generation. And so I enjoy the when I have time and to really spend time with team members who are coming into this space.
Really wonderful, and I love the transition from the technology to the people and the emphasis and everything you said. I totally concur with. Now, I can't let you go without asking you about your passion for open water swimming, which I think means a whole bunch of crazies down at the shores of Lake Champlain and jumping into the water in the middle of the winter. Is that what you do?
Well, yes, but let's be really clear. I'm not one of those crazy people who jumps in there in a Speedo. So Ted, I've got a wetsuit on, just to be really clear. But yes, I suffice it to say, I did enough running and playing football growing up that my knees are maybe well, they've recently been through a little repair job. So swimming has become my new thing. And so yes, Lake Champlain. And yes, it gets cold in the wintertime, but that's what wetsuits are for, right?
That's right. Oh, how great. Wait, listen, thanks so much for being on the podcast.
Appreciate it.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.